Okay, so this is 7-5, and we're looking at systems of inequalities. We've already looked at systems of equations, both linear and nonlinear, and now we're going to look at inequalities. So recall, it makes a difference whether we have less than or greater than, or less than or equal to, greater than or equal to. If we don't have the little line underneath, we have a dashed line. If we do, then we have a solid line. And then we can determine whether shading above or below the line. So greater than, less than. If it's greater than or equal to, we're shading above the line, and vice versa. Now, if y is negative, so we have a negative y, then the opposite is true. So greater than would actually mean shade down, and less than would actually mean shade up. So I'm going to go ahead and get started with some examples here. Let me go ahead and set these up and draw our x and y axis. And now we have y is greater than negative 2/3 x. Well, we know how to graph the line negative 2/3 x. We have a y-intercept of 0. Our slope is negative 2/3. And because it's just, there's no equal to sign, we're going to be drawing a dashed line. And then we need to determine whether we're shading up or down. Y is positive, so being greater than, we would shade above the line. I recommend using a highlighter because you can still see through it and it's very clear. You don't have to use a highlighter. Looking at our next example, we have y is less than 3. Now there's no x value here, so we want to make sure that we're careful here. This is going to be a horizontal line through the point y equals 3. And it's equal to, so it's going to be a solid line. And then we can decide, are we shading above or below? It's saying y is less than, so we can shade below. Okay. Moving up a little bit, it says graphing nonlinear inequalities. What if what we're graphing is not a linear equation? What if it's a quadratic or something else? So what we can do then is we can graph the equation as if it were an equal sign. And then we're going to choose a test point to decide if it was shaded inside or shaded outside. If we get a true statement, we shade on that part of the graph, and if not, we shade on the other part. So let's go ahead and get into some of those examples. Our first example here, we can recognize that this is the shape of a circle. So, setting up our graph here. And this would be with a radius of 3. And it's going to be solid because we have the line there. And now I need to choose a test point. Now the easiest test point is to choose is 0, 0. So if I plug in 0 here and 0 here, 0 squared is 0, 0 less than or equal to 9. So 0 is less than or equal to 9. That is true. So we're going to shade on that part of the graph. So it would be on the inside. And that's it for those. And then looking at graphing systems of equations and inequalities. So now we're back with a system of inequalities. It says graph one equation, graph the other equation, and then the overlapping part is the solution. So we have the system of inequalities here, and let's go ahead and graph each one of those. So this first one, I can rewrite these equations, and I'm going to write them in slope-intercept form. This first equation here, if I subtract x over and divide by -1, remember when you divide an inequality, it is facing the other way. And we have an equation of y is greater than x minus 1. And then for the other one, we would have y is greater than or equal to negative 2/3 x plus 4. And now I can graph both of those. Okay. So graphing that first equation, we have our y-intercept, our slope, and I'm going to extend this pretty far. And it's a dashed line. and then I'm going to graph the other one in another color. So up 4, and then I have a slope of negative 2/3. And this is why it's so important to graph with detail, because now I can see exactly where these two lines are going to intersect. This is going to be a solid line. And now I can shade. Now for that one, we are shading above. And for this one, we would be shading above. So my overlapping area here is my solution. Okay. So we've got 2 more examples. Let's go ahead and look at number 2. Now, one of these is a linear equation. The other one is not. The other one is a quadratic equation. So let's go ahead and look at what that might look like here. So this first graph is in a nice form for us, and we can just graph this quadratic equation the way we already know how. And it's a solid line, so that's nice. And we can choose a test point. If I plug in 0, 0 and 0, 0 is greater than -4, so we would be shading above here. And I'm just going to really lightly shade. And then I can draw my other one, this line. And if I rewrote this, well, you know what? I'm actually going to do it without rewriting it. We have this point right here and this point right here. And we have a solid line as well. And I'm actually going to be shading down, even though it's facing the y. Because y is negative, we have to follow the opposite rule. So that would be shading down here. So my overlapping part would be this little part in here that's below that line, but above that parabola. So that would be my overlapping part. We have one more example, and now we have 3 inequalities here. It makes it a little bit more work for us, but it's not any more difficult than the other examples. So I'll go ahead and draw those. I'm going to do these each in a different color so we can keep track of them. This will be my first one. And this is a dashed line. And then this one right here, we have x is less than 4. So at 4 we have a vertical dashed line. And then at x is greater than or equal to -2, so we have a solid vertical line there. And then we have y is less than 3, so we have a dashed line through there. Now, we haven't done any of our shading, so let's just go ahead and do that real quick. We have y is less than 3, so I'm just going to lightly shade on this side of that line. And x is between these two values, so it would be in between here. And then for this one, it says y is less than, but because it's negative, it's actually greater than. And so our overlapping area would be this trapezoid shape here. And that's our shaded region. And that is actually the end of 7-5.